Hello everyone, this is Dr. Webb. So over the next 4 videos, we're going to be talking about exponential functions and their derivatives, and then logarithms and logarithmic functions and their derivatives. So let's get started going over a quick review of exponential functions. Okay, so let's go way back and let's think about linear functions. And so if we have a function that's linear, what defines a linear function is that it has a constant slope. Okay. And so what this means, one way to think about this constant slope is that if we take the difference of function values when we increase x by 1, it's always going to be the same. So the idea is if you have, sort of using the slope function, f of x over x plus 1 minus x, right? Well, by the slope function, this will give you the slope. But then if you, on the bottom, you'll notice that if you have the x plus 1 minus x, the x's there cancel off. And so this whole thing right there simplifies to just f of x plus 1 minus f of x is equal to the slope m. Okay, and so here's a table of values for a linear function. And if you notice, as you go from 0, 3 to 1, 5, what's the difference in the y values? The difference in the y values there are, so really this should be delta y is equal to 2. What's the difference between 5 and 7? Y is changed by 2. What's the difference between 7 and 9? Y is changed by 2. And for all of these, delta x is equal to 1. And so what's the slope of this function? 2 divided by 1 gives me 2. Okay, so the change for exponential functions is that instead of a constant difference when we increase by 1, we're going to have a constant ratio in the y values when we increase by 1. So for this one, instead of having a common difference of 2, we're having a common ratio between two values is equal to 2. Right? So it still starts at 0, 3, and then the next one is 1, 6. And if you look, what's 6 divided by 3? That's 2. Then between the next two values, it goes from 6 to 12. Well, what's 12 divided by 6? It's also 2. Then 24, then from 12 to 24. What's 24 divided by 12? 2. Finally, 48 divided by 24, 2. Right? So to go from each next one in the table, we're going to multiply by 2. So the one after this, when we get to 5, it's going to be 48 times 2, which is 96. Okay, so this gets us to the standard form of an exponential function. So it's y is equal to c is a constant times another constant b raised to the x power. So it's c times and then b raised to the x power. Okay, the b here is the common ratio. Like we saw in the table before, the common ratio before was 2. This base, b stands for base, is what's going to be the common ratio between when you increase x by 1. If b is bigger than 1, that means as x gets bigger, the function's growing bigger. And this is when we have exponential growth. If b is smaller than 1, and really it should be 0, we don't really care about negative bases. It's for negative bases, it's not really defined over all the real numbers. So if b is between 0 and 1, that's when we have exponential decay. And so what that means is that as x gets bigger, the function actually gets smaller and smaller and smaller and goes towards 0. Okay. This function, this value constant c, well, it's sort of like plays the role of the y-intercept in when we talk about the points, the slope-intercept form of a line. It is the value of the function at x equals 0. It's the place, it's the y value when c crosses the y-axis. Okay, so here's a graph of an exponential function. Because the function's going up, this is exponential growth. So this is showing growth here. If you've been looking at the news lately, this might look pretty familiar. A lot of graphs about COVID cases, at least initially on, showed a lot of exponential growth. And so they often look kind of like this. It's the same basic shape. So if we want to know what the value, what the equation for this is, well, we see that it's passing through the y-axis at 4. So it's going through the point y4. And so that's telling us that in the standard form, this c value is going to be 4. Now, to figure out what the base is, we're going to look at what the ratio between the different values are. So when x is equal to 1, the y value is 6. When x is equal to 2, this looks like it's halfway between 8 and 10. So it looks like it goes through 2, 9. Right? So let's look at what the ratio between these successive terms are. So between these two terms, that would be 6 over 4, which is 3 halves. Between 9 and 6, 9 divided by 6 is also equal to 3 halves. So we have our common base. B here is 3 halves. And so our total function, C is 4. B is 3 halves, same as 1.5. And so our function here is y is equal to 4 times 3 halves to the x power. Or we might write it as 4 times 1.5 to the x. Okay, and that's our exponential function. Okay, so similar to a line, if you know 2 points on a line, that's enough to give you the full equation of the line. It's exactly the same with exponential functions. So if you know 2 points on an exponential function, there's only one exponential function that goes through those 2 points. Okay, so for this example, let's find the equation of the exponential function that goes through the points 1, 12, so 1, 12, and 3, 4 thirds. Okay, so our function looks like c times b to the x. From the first one, we know that when x is equal to 1, so they give me c times b to the first power, y is going to be equal to 12. From the second set of points, this is telling me that when I raise b to the third power, my y value is 4 thirds. Okay, so using these two equations, I need to solve for both c and b. Okay, so the trick here is that if I take 4 thirds and divide that by 12, well, 4 thirds is c to the b cubed divided by c to the b to the first power. So over on the left-hand side here, I've got 4 thirds divided by 12. This is the same thing as 4 over 3 times 12 is 36. On the right-hand side, I have c times b cubed over c times just b. Well, I can cancel off these c's, and b cubed divided by b, that's going to cancel off to b squared. So I have 4 over 36 is equal to b squared. 4 over 36, this actually cancels out to 1/9. So 1/9 equals b squared. So that tells me b is equal to 1/3. That's the square root of 1/9. And considering that b has to be positive, I can ignore the minus 1/3. The only positive root there is 1/3. And so now that I know that b is 1/3, I can go back to this first point, and I have that 12 is equal to c times 1/3. If I multiply both sides by 3, I get 36 is equal to c. So c is 36, b is 1/3. So my function here is y is equal to c, which is 36, times 1/3 to the x power. And we can double check this. When I plug in 1 into here, 36 times a third gives me 12, so that works out. When I plug in 3, I'm going to get 1/3 cubed is going to be 1 over 27. 36 divided by 27, I can cancel a 9 out from both of them and end up with 4 over 3. So this works exactly right. That is all for this video. See you again soon.